Franziska Uhl is this year's Jon J. Rood Award winner, and her work looks at the impact of metabolic reprogramming of donor T cells. Franziska, what does metabolic reprogramming mean, and how did you do it?
So metabolic reprogramming is actually a process which is known for many cell types. So in T cells, a naive T cell watches and waits for its antigen, and at that time it wants to use energy as efficiently as possible. It basically relies on oxidative phosphorylation. During activation, the T cells undergoes metabolic reprogramming, so it upregulates its aerobic glycolysis. And in this aerobic glycolysis, the pyruvate is then fermented to lactate. This process is much faster than generating energy through OXPHOS, and it has different functions, including providing building blocks, for example, for cellular growth and proliferation. And we've observed that in AML patients with a relapse after allogeneic transplantation, they have a severely disturbed metabolic T cell phenotype. And we used a treatment strategy with sodium bicarbonate, and this actually restored the metabolic reprogramming in the T cells and thereby provided a better anti-tumor control, which we could show in graft-versus-leukemia models in the mouse.
How does it enhance graft-versus-leukemia effects, and how effective was it in your study?
Okay, so mechanistically, the lactic acid, which was produced by the AML blasts, reduced the intracellular pH in the T cells and corrupted the metabolite concentration and composition of the T cells. And this led to a severe reduction in many key metabolic pathways. And the sodium bicarbonate then restored the intracellular pH back to a neutral level and also restored this metabolite composition in the T cells, increasing glycolytic metabolites and nucleotides, which is very important for the metabolic reprogramming and for example, the proliferative capacity of the T cells. We've observed basically a full recovery of the metabolic phenotype in cell culture, and we took this into the mouse model where we used sodium bicarbonate treatment also in graft-versus-leukemia models, and could see that now the mice survived much better when they received T cells and a sodium bicarbonate treatment at the same time. So we went back from the bench to the bedside and used sodium bicarbonate in patients and administered to patients with an AML relapse after allogenic transplantation. And these patients also received donor lymphocyte infusions at the same time. And we observed that the T cells of these patients had a much better respiratory activity now. And this was accompanied by a much better effector cytokine production. This is a strong indicator that we also increase the anti-tumor control of the T cells in these patients.
So what's next for the research?
We believe that the treatment we discovered during our study could benefit many patients. So we propose larger randomized clinical trials to look for long-term outcome and benefit in patients with an AML relapse. So we've seen these effects on allogenic T cells. So we propose the comparison of patients already receiving donor lymphocyte infusions compared with patients receiving the DLIs and the bicarbonate treatment at the same time. We also are interested in changes of the T cell phenotype during the bicarbonate treatment. So there is a collaboration planned with a group who specialized in CyTOF technology. And again, from a mechanistic point of view, it would be also interesting how and if the sodium bicarbonate is actually metabolized in the T cells. And this could also provide further insights into the treatment strategy.
What does it mean to you to win the award, and what's next for you personally?
This is a great acknowledgement of the work we've done, and also acknowledgement for all the collaborators. I, for myself, am changing my personal and professional life right now. So in a few days, I'm defending my doctoral thesis. So please, everyone, cross your fingers. And I actually, just at the beginning of the year, moved to Munich, and I'm taking my first career steps in pharmaceutical industry because I'm very much interested to contribute my knowledge in hematology and immunology to contribute to the next steps necessary to bring innovative treatments to patients.